Today, I will be going over the anatomy of the modern case, going over the modern casing weaknesses and potential improvements, and finally answering the question, how does the shoulder angle of a bottleneck case affect the performance of the cartridge? Firstly, the case body. The case body holds the power and provides structural integrity during firing. Next is the shoulder, right here. The shoulder is the angled part that narrows into the neck that's helped guide the bullet into the chamber. Next is the neck. The neck is where the bullet gets seated and held securely in place. Next is the extractor groove, right here. It allows the case to be grabbed and ejected after firing. Different rim designs suit different firearm types and feeding systems. Modern cases are designed with efficiency, safety, reliability, and performance in mind. Efficiency with a powder burn comes from the bottleneck design and improves velocity and consistency. Reliable feeding, extraction, and semi-auto and fully automatic weapons, heat and pressure resistance coming from the brass or polymer cases that handle these high pressures really well. Reloading as well with brass casings. Head spacing accuracy ensures tight chamber fit, accuracy, and safety. Modern cartridge cases, especially those in military and civilian firearms, have evolved to be highly efficient, reliable, and accurate. However, like any design, they are not perfect. Through research and practical observation, a few weaknesses still are there. First one, heat retention and barrel fouling. One issue with brass casings is they conduct and retain heat after rapid or sustained fire. This heat can transfer to the chamber and cause cook-offs or extraction problems. Additionally, carbon and unburnt powder residue inside the case contributes to chamber fouling. Two things that could go into potential improvement are you're using polymer or hybrid case materials with internal insulation, or lighter weight casings that cool faster and reduce that thermal transfer. Another weakness is the weight and carry load. Brass cases are relatively heavy, especially in bulk for soldiers or hunters carrying large quantities of ammunition. I can attest to that. This adds a lot of significant weight. Potential improvements might be able to be using lightweight composite or polymer cases, or using telescoped ammunition where the bullet is partially enclosed in the case, so it reduces the weight and volume. Weakness number 3, case capacity limitations. Conventional cases shapes can limit the amount of powder or how efficiently it burns, especially in a straight-walled or older designs. Potential improvements might be develop caseless ammunition or electronically ignited cartridges for more efficient powder usage, or modifying the case's geometry, sharper shoulders or longer necks for better burn characteristics. How does the shoulder angle in bottleneck cases affect the performance of the cartridge? The shoulder angle of a bottleneck cartridge case can significantly influence its performance in several ways. A steeper shoulder angle typically results in more efficient combustion by promoting consistent powder burn and reducing case stretch, which can enhance accuracy and prolong brass life. It can also help with head spacing and contributing to more precise chamber alignment. On the other side, a more gradual shoulder angle may improve feeding, reliability, especially in semi-automatic firearms, and facilitate a smoother extraction. Ultimately, the ideal shoulder angle depends on the intended use of the cartridge, whether it's for precision shooting, hunting, or tactical applications, as it represents trade-offs in ballistic efficiencies and mechanical reliability. While modern cartridge cases are highly refined, there is still room for improvement in terms of weight reduction, thermal efficiency, case geometry, and material innovation. These improvements would not only enhance ballistic performance, but also make ammunition more efficient, reliable, and adaptable to future firearm technologies.